Hello, everyone. Today, let me introduce SecGear, the unified computational computing framework from OpenOla community. I'm the computational computing fig manager, Pritika. Okay, I will introduce below contents. First, what's computational computing, and the pinpoint multi-architecture pinpoint of computational computing, and also our SecGear framework, and explain why SecGear makes computational computing simple. Okay, first, what's computational computing? Computational computing is actually a technology that emerged to resolve data in use protection. As we know, we have the secure storage to protect the data in rest, and also quite several security protocols to protect the data in transmission. But how to protect the data in use is the topic. Actually, computational computing technology is to resolve this problem. So, usually the hardware computational computing technology can be simply abstracted as that put the running data into a black box, and the application can only request computation of the data, but it can't take any data out of the box. Currently, there are several hardware solutions that supply the functionality. First, Intel has the SGX, and also Intel new hardware has the FKTME. For ARM, it's Trezor, and for RISC-V, there is the pistol solution for this. From the design perspective, actually the different hardware architectures have different design principles. For example, the SGX partitions some memory addresses as secure container to ensure the security of the memory in the addresses. And the Trezor construct the two paths, secure and insecure world, through the time division multiprocessing of the processor to achieve the security. That in secure world, the data cannot be the memory cannot be accessed directly from the insecure world, so that the private data can be protected. And as we know, currently the public cloud is a trend for the industry. But some customers are still hesitant to migrate their business to public cloud. The main concern is data leaking. The business data is very important for the customer, and some customers worry about that if their business are migrated to the public cloud, the data protection is out of control. So actually, the computational computing technology is a good fit to resolve this problem. Okay, let me introduce why multi-architecture is a pinpoint of the computational computing. Actually, from what we just introduced, there are several hardware solutions. Each hardware solution usually has its own SDK, and those SDK are not compatible. If a developer write a computational computing application in one SDK, actually it can't be running on other SDK. They are ecological isolated, and also if the developer wants to porting their applications from one SDK to another, actually the effort is quite high. So also if the developers really have the two hardware solutions that it needs to compile with, then it has two sets of the source code. The maintenance cost is quite high. Okay, then let me introduce our SecGear framework. From the stack, you can see the SecGear framework supplies several layers. The base layer supplies the unified basic API to the applications, and the middleware layer supplies several standard middleware implementation for developers. And also the service layer. Service layer is a ready-to-use layer that can be deployed directly. So first, let's have a look at SecGear base layer. SecGear supplies the basic interfaces for the customer to develop their trusted application. And the library supports standard POSIX API and also standard OpenSSL API on the secure one. Users can develop the secure application based on these interfaces. And our goal of design is to let developers have the same programming interfaces on secure side as on ethical side. And also let developers have consistent programming interface experience in different architecture solutions. So from this page, you can see there's a comparison of the interface supplied by Intel SGS and also by the global platform standard interface. From the comparison, you can see the global platform interface is quite complicated. It's designed for the mobile phone scenario. Actually, on the server, it does not have the ecosystem. So its interface is quite complicated. So our objective is to simplify the global platform interface using the SecGear, and we referred to the Intel SGS style interface and unified the interfaces to a similar way. And after the implementation, that the interfaces are unified to one style, and the developer can easily develop their applications based on the unified interfaces. And for the middleware layer, we supplied several standard protocol implementation, including PKCS11, TLS, and PKE. PKCS11 use the enclave environment as the backend encryption device and provide a standard PKCS11 interface. And TLS is the TLS provides the secure transmission protocol for direct interaction between the enclave and the clients. As we know, TLS is widely used in many scenarios, such as secure communication and secure database connection. And PKE is the key exchange protocol that enables the user can negotiate encryption key between the client and the enclave. Then the data can be transmitted into enclave with the secure protocol, with the encrypted protocol, so that it's secure. That is just simple showing that our TP set 11 library compatible with the standard interfaces and user the user application even don't need to be modified. That's linked to our library. It can use the enclave. And for the service layer, SecGear provides a key management service called eKMS. It uses the enclave as the encryption devices. All the key generation and encryption decryption operations are inside the enclave to protect the security of the keys and also the process of encryption and decryption. So using the SecGear eKMS is more secure than the common KMS service. Okay, why SecGear is make confidential computing simple? I think from the above introduction, you should have already have an idea. Actually, the SecGear supports multiple architectures and multiple hardware solutions and supplies the unified programming interface to the user. And when user need to support more than one hardware solutions, using SecGear is quite effort saving. For example, it can use one unified source code for different architectures, and also the maintenance and development effort are reduced. So in summary, the SecGear supplies the base layer that have the standard interfaces and the middleware layer that has standard protocol implementation, and the service layer is ready to use and ready to deploy. So SecGear makes the computational computing simple. Okay, that's what I want to introduce for today. And welcome to follow our community.